Welcome to Navadhi Vidyalaya Samadhi's e-content. Today we are studying about polynomials. What is the geometrical meaning of polynomials? Then we know the standard form of linear polynomial is ax plus b, a not equal to 0. That is, the 0 of the polynomial ax plus b is x is equal to negative b by a. Then geometrical meaning of zeros of polynomial means we are drawing this graph on a sheet of graph paper and we can find out the values of x from the graph. That is the meaning. Then consider the example 2x minus 4. If we put different value for x, we know x is the variable. We can put different value for x. We will get different value for the polynomial. Then suppose x is equal to 1. What will be the polynomial? P of 1 is equal to 2 into 1 minus 4, which is equal to negative 2. If x is equal to 2, the polynomial becomes 2 into 2 minus 4, or 4 minus 4 is equal to 0. Then if x is equal to 3, the value of the polynomial becomes 2 into 3 minus 4, 6 minus 4 equal to 2. X is equal to 0. What is the value? The polynomial becomes 2 into 0 minus 4 equal to negative 4. If you substitute negative 1, 2 into negative 1 minus 4 or equal to negative 2 minus 4, which is equal to negative 6. Then if x is equal to 1 by 2, it becomes 2 into 1 by 2 minus 4, which is equal to negative 3. That is, we got the values, different values of x and polynomial p of x. By taking the values of variable x and the corresponding values of polynomial as ordered pairs, we can plot the points on a Cartesian coordinate system. Then we can plot the points on a sheet of paper, graph paper. We will get the graph. Here the ordered pairs are, first pair is 1 and negative 2. Second pair 2 0, third pair 3 2, 0 negative 4, negative 1 negative 6, 1 by 2 and negative 3. Now we can see if we plot the points on a sheet of paper, we will get the graph like this. It will be a straight line. Now we can see this graph intersect the x-axis at one point. That is the graph of the first degree polynomial 2x minus 4 is a straight line, and hence the name is called linear polynomial, or representing a line. The graph intersects the x-axis at 2 0. That means the 0 of the polynomial is x is equal to 2, which is the x coordinate where the line meets the x-axis. This is because of the fact that the value of the polynomial is taken as the y-coordinate of each point, and y-coordinate of the point on the x-axis is 0. In general, we can say that the x-coordinate of a point where the graph of the polynomial meets x-axis 0 as the 0 of the polynomial. We know the linear equation has only one 0, hence the graph intersects x-axis at only one point. Consider a quadratic polynomial. We know the general form of the quadratic polynomial is ax square plus bx plus c, where a not equal to 0 and a, b, c are real numbers. Consider an example. Suppose p of x is equal to x square minus 4. Then as in the case of linear polynomial, we can put different value for x. Suppose x is equal to 1. What will be the polynomial's value? 1 square minus 4, that is 1 minus 4 equal to negative 3. If x is equal to negative 1, the value becomes negative 1 whole square minus 4 equal to negative 3. Then x is equal to 2 means 2 square minus 4, that is 4 minus 4 equal to 0. X is equal to negative 2 whole square minus 4, which is also become 0. Then x is equal to 3 means 3 square minus 4, 3 square is a 9, 9 minus 4 is equal to 5. Now we got the values of x and p of x. Now we can take the ordered pairs. Which are the ordered pairs? 1, negative 3, first pair. Negative 1, negative 3, second pair. Third pair, 2, 0. Fourth pair, negative 2, 0. Last pair, 3 and 5. We can plot the points on a sheet of paper. Now we can see that the graph is, we will get a graph like this. The graph intersects at two different points. The name of the graph is known as parabola. The graph intersects the x-axis at 2 points, that is 2, 0 and negative 2, 0. Thus we can conclude that a quadratic polynomial has at most 2 zeros. The shape of the quadratic polynomial is a curve which is known as, the name of the curve is known as parabola. The parabola can be open upwards or open downwards. The number of zeros will be number of points where the graph meet x-axis, and zeros of the coordinates of points where the graph meet x-axis. Hence we can conclude that for a quadratic polynomial ax square plus bx plus c a not equal to 0, the graph of the corresponding equation is either open upwards or open downwards, depends upon the value of a. That is, if open upwards means a greater than 0 and open downwards means a less than 0. The name of the polynomial is, that is a quadratic polynomial. The curves are known as parabolas. Maximum it has 2 zeros. Then maximum zeros are 2. Then which are the possibilities of this shape? What type of graph we can obtain from a quadratic polynomial? Let us see. The shape of the graph of polynomial ax square plus bx plus c, we already studied, it is a parabola. Then there are 3 cases will occur. In the first case, the graph intersects at 2 different points or 2 distinct points. In the second case, the graph intersects at only 1 point. And third case, it will not intersect. That is, maximum it has 2 zeros, isn't it? That means it may have 1 zero or no zeros. Let us study one by one. In the first case, the graph cut the x-axis at 2 distinct points. See the figure, open upward and open downward. Here the graph intersects x-axis at 2 distinct points, a and a dash. That is, 2 different zeros will be there. This is the first case. In the second case, the graph cut the x-axis exactly at 1 point. That is, it just touches the graph x-axis at 1 point. That means 2 roots are same roots, coincident roots. We can see that a and a dash, both roots will be same. Coincident root means same roots will be there. That is, here also we can expect open upward and open downward. The coordinate has only 1 0. That means open upward or open downwards. In the third case, we can see that the graph is completely above the x-axis or completely below the x-axis. That means it does not touch the x-coordinate, isn't it? That means we don't have any zeros here. That is, for a quadratic polynomial, we have either 2 zeros, that means 2 distinct zeros will be there, or 1 zero will be there, or it has no zeros. That means a quadratic polynomial has at most 2 zeros. Now we can move for the next type of polynomial, that is a cubic polynomial. We know the general form of the cubic polynomial is ax cube plus bx square plus cx plus d, where a not equal to 0. Consider a cubic polynomial, x cube minus 4x. Here we know x is the variable there. We can put different value for x. If we put x is equal to negative 2, the value becomes negative 2 whole cube minus 4 into negative 2, the value becomes 0. If x is equal to negative 1, the value of the polynomial is negative 1 whole cube minus 4 into negative 1, that becomes 3. If x is equal to 0, the polynomial becomes 0 cube minus 4 into 0 is 0 only. If x is equal to 1, the value of the polynomial is 1 cube minus 4 into 1, which is equal to negative 3. And x is equal to 2, the value of the polynomial is 2 cube minus 4 into 2 is equal to 0. That means after drawing the graph will be two parabolas joining together, like that we can see. One is upward and one is open upward and open downward. We can see a figure like this. That means the graph intersects the x-axis at two distinct points. Where which are the points? Negative to 0, first point, second 0, 0, and third point is 2, 0. Hence we can see that the graph intersects the x-axis at negative to 0 and 2. That means the cubic polynomial has maximum 3 zeros. That is, for any cubic polynomial it has maximum 3 zeros. In general, we can say that for a polynomial of degree n, the graph of y is equal to p of x intersects the x-axis at most n zeros. Therefore, a polynomial of degree n has at most n zeros. It is a linear polynomial has 1 zero, quadratic polynomial has maximum 2 zeros, and a cubic polynomial has maximum 3 zeros. Thank you.